Hello there, I'm Thomas Hatsios, a British American pilot flying the Boeing 777 300ER international flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, and then coming back to the Zurich International Airport. Runway 14 for an Ilsloc localizer. Landing Suriname with the cockpit for the takeoff preparation of the Boeing 777 300ERX of the Pmdg simulation microflight simulator X. So I'm gonna start showing you the cockpit instruments and the displays of the Boeing 777-300 ER airplane. I'm gonna start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel. The radio altitude above the ground level, the ground speed, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the FUS, the heading selected from the autopilot and flight director system panel, the magnetic north pole and true north pole, and the magnetic variation depending on where we are in the world. We also have the rate of climb and descent of the aircraft in tens, hundreds, and thousands of feet per minute or at trigonometric angle in degrees. We have the pitch ladder in degrees, and the altitude indicator and the bank angle in degrees. Also the flight director crossbars for manual guidance of the aircraft, the ILS localizer crossbars, and the autopilot crossbars for automatic guidance of the aircraft. We have the angle of attack of the aircraft as it flies, and also the flight mode annunciator with the autopilot and not throttle. Later on in vertical navigation modes, we have also the navigation display. The navigation display displays the airports, the waypoints, the nav aids. We have the GPS position of the aircraft and terrain and weather reflection from the weather radar. So you can see the terrain levels with red, green, and yellow. The elevation above the sea level. Also the sea and the lakes and the rivers. We have again the magnetic north pole and the true north pole, the magnetic variation depending on where we are in the world. We have the heading on track. We have the ring in distance in nautical miles. We have also other aircraft flying around our own aircraft, as you can see over here in the navigation display. So you can see other aircraft using the ATSP and ADC transponder that transmits and receives our position and altitude, and also receives from other aircraft the distance, the difference of altitude, also the direction and the airspeed. Using the TICA system, the traffic collision alert system that generates also the warnings in the navigation display. So it's a passive radar. You can see other aircraft flying. So we have also we can use the flight management computer to generate our route, complete flight plan using a departure airport with the standard instrument departure, the seat, the departure runway, and also the donated waypoints and navigates, destination airport, the stars, the starter terminal arrival, fixes and waypoints, and also the ILS localizer runway and frequencies. So we select a departure airport and a destination airport and a departure runway and a destination runway, and we make a complete route for vertical and later on navigation flight path. So you will see also that it will be displayed in the navigation display as a purple line from the departure runway all the way to the destination. So after that I'm gonna come to the autopilot and flight director system panel. I will show you the autopilot engage and disengage switches, the auto throttle engage and disengage switch, the auto throttle, the flight director engage and disengage switch. We have also the airspeed select node. You can select the airspeed in nautical miles per hour, knots, or Mach speed. So we can select also the flight level change, the auto throttle hold with the speed mode, and also the climb continues. So we have different modes of operation for the airspeed using the engine thrust produced and the auto throttle. So we can use fixed thrust like takeoff, go around, climb, and also descent, where we have maximum climb thrust for the climb or idle thrust for the descent, and also we have variable thrust for cruising and for approach and landing. So when we have fixed thrust for climb or descent, the airspeed is being adjusted by varying the rate of climb descent of the aircraft by using the elevator, the horizontal stabilizer frame. So also I'm gonna show you the LNAV and the VNAV, the lateral navigation, the vertical navigation modes of the autopilot and flight director system panel of the Boeing 777-300ER. That is interconnected with the flight management computer modes. I will show you also the bank angle limit select knob, the heading select knob, and the heading hold switch. Also the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands of feet per minute or at trigonometric angle increase. Also the altitude select knob and the altitude hold switch, and also the VOR localizer switch for the Lszh localizer approach, and also the approach switch for the autoland function of the Boeing 777-300ER airplane. Then I'm gonna come to the thrust levers, show you the function, explain you the function of the thrust levers that control the engines of the Boeing 777-300ER functions. So we have the General Electric 90, the G90 installed in our airplane, which are turbofan turbojet engines. Also, I will talk to you about how to use the thrust levers in their connection with the auto throttle system. I will show you also the upper and the lower ACAS and the indication accrual alert system that displays information using the FADEX, the full authority digital electronic control computers that are installed in our engines of our airplanes. So we have the information like the N1, which is the low speed starter and start, the low pressure compressor and turbine of the turbofan turbojet engine, the exhaust gas temperature, the N2, which is the high speed starter and shaft, and the high pressure compressor and turbine of the turbofan turbojet engine, the fuel flow per engine per hour in thousands of kilograms or in thousands of pounds, and also the oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So you will see all these things over here in the panels, as you can see, of the Boeing 777-300ER. You see the upper and the lower ACAS that display the engine information. I will show you later, and the thrust levers we use to control the engines functions. So you can see also the yoke for the flight controls. So after that I will explain you about the flight theory of the Boeing 777-300ER airplane, about newtons per second total of kinematic motion, the Boeing theory of fluid, about aeronautical and aerospace engineering principles we use also for flying the airplanes. So I will come later to the takeoff speed calculations, also the forces of that make the airplane fly, like the lift, the weight, the thrust, and the drag, the aerodynamic lift from the wings, and I will show you then the flight controls. The yoke of the Boeing 777 controls the horizontal elevator, the horizontal stabilizer elevator section, and also the ailerons and the spoilers in the left and the right wing, and also the vertical stabilizer rider using the rudder pedals. I will show you how to control the non-wheel steering using the tiller and other functions. Then I will come to the overhead panel, show you the electrical system, the left and the right engine, IDG, the great drive generators that produce alternate current by the engine's rotation. So I will show you the batteries, the primary, the APU battery, also how to start the APU. We need the APU, the auxiliary power unit, for starting the engines in the ground. I will make an engine start demonstration so show you how to do that. I will show you also the ADIR, the air data inertial reference unit, the primary flight control computers, the hydraulic system, the left and the right engine driving hydraulic pumps, the C1 and C2, which are also pressurized by air, by bleed air from the engines or the APU. Also, I will show you the electronic engine control for the engines that controls also the FAREX, the fuel authority, the electronic control computers, the auto start system, the fuel system with the fuel tanks and the fuel pumps and the low and the high pressure fuel valves for the engines. Also the left wing and the right wing and the center tank of the aircraft. I will show you also the wing and engine ADIs, the cabin pressurization system and the bleeder from the left and right engine that is being used for cabin pressurization, wing and engine ADIs, air conditioning and ventilation, and also for the hydraulic fluid pressurization that also supplies pressurization to the flight control system. So we need pressurizer from the engines for that, also from the APU, from the auxiliary power unit for starting the engine in the ground in a cold and dark state. I will show you also that. I will make an engine start demonstration. Let's set up the flight management computer and make a small flight. So thank you very much one more time for joining me. I'm Thomas Hatsios, the British American pilot flying the Boeing 777-300ER United Flight. So I will start now with the cockpit of the Boeing 777-300ER. We have about an hour and 3 minutes left for this flight. As you can see, we have everything here inside the cockpit. You can see also the outside of the aircraft of the Boeing 777, where we are located right now in the airport. So it's a Zurich International Airport. So you can see here, for instance, the flight controls, the control column. We'll talk to you about later. So we'll start with the primary flight display. You can see the primary flight display, the airspeed indicated, the airspeed tape, the airspeed selected from the autopilot and flight director system panel, the ground speed, which is 0 right now, so we're not moving. We have also the barometric altitude above the sea level. This is the altitude tape, the altitude selected, the target altitude selected from the autopilot flight director system panel, also the target airspeed, the target heading, with the heading, magnetic heading and track, and the rate of climb and descent of the aircraft. So this needle, when it moves up, the aircraft climbs. When it moves down below the altitude, the aircraft descends. So you have to pay attention to that. We have also the flight director here, the other indicators. You can see the pitch ladder increase 2.5, 5, 7.5, 10, 12.5, 15, 17.5 to decrease of plus or descent. Of climb or descent of the aircraft. Also the bank angle like 45, 33, 20 degrees. So you can see here we have also the flight mode annunciator with the autopilot and flight director system panel modes. You can see here we have we can set these in inches of mercury for the barometric pressure or hectopascals, also to set the meters. For display, we have the north here, magnetic or true, so you can set the true north pole over here, and now we have the true north pole for navigation. You can see it display here with the track or here. So we can change again back to the magnetic like this. So we have now the magnetic north pole for navigation. You see the mag here. So now we will come here in the rest of the cockpit. You can see the autopilot and flight director system panel, the autopilot engage and disengage, the auto throttle left and right. So we have auto throttle left off. You will see the auto throttle with yellow left off. Now we can use the other throttle right, and we have the other throttle left, right, off, as you can see. And display here. We have also this mode, the airspeed select mode, the airspeed in nautical miles per hour, flight level change, climb continues, the LNAV and the VNAV, the flight director here on and off, the switch. So we set back this. You can set an airspeed above or below, like 253. It will display over here in the primary flight display on the other side, if you want to see. So we have also the angle of the aircraft as it flies, the limit, the heading select, on and off. All these modes are depressable. If you press other switch, we'll select the heading or track over here, like 136 degrees heading or track. Also the altitude over here, you can select one mode at a time. Set the target altitude 35,300, and you have the hold also switch for this mode. So you can see now we have a different kind of information for the flight director. You have flight level change, speed, heading, hold 253 nautical miles per hour, the target airspeed. Now we're not moving, but it's for after takeoff. The pitch ladder in degrees and the target altitude over here 25,300 feet or 7,710 meters. You can see our own altitude right now is 1,430 feet above the sea level, 436 meters. Hectopascals again 1030, or inches of mercury. Inches of mercury again. So we can set also over here the autopilot on. You will see all this information again with the autopilot here on. Flight level change. We can set also the other side, the altitude hold over here. So one mode overlaps the other and it cancels. So we can use only altitude or flight level change speed for the climb mode. We have also the vertical rate of climb descent, flight path angle. You will see the descent, the minus descent right now, minus 3.6. It will display over here. The purple lines, as you can see, below the axis in the flight director, and also the positive the other way up if you want to climb 3.5 degrees up and down using this slider. So it will display over here 3.5 degrees above the horizon line, this purple mark. If you have a glide set with this mode, the flight path angle and the heading hold. Also we have vertical speed, flight path angle, and thousands of feet per minute. Like if you want to descend, over here you will see minus 2,900 over here in the rate of climb descent, this mark that designates the climb or descent point. So now we're gonna have how fast we will climb or descend. So now we're gonna have the positive. You will see the plus again for this mode over here, and the positive climb over here in the rate of climb. This states the VSI, the vertical speed indicator. So got more things to note here. We have the autopilot on, so maybe also we need to use the altitude. You will see the altitude now engaged with the autopilot, and again the flight level change, and we have like less than 1 hour left for this flight. So we have heading hole, flight level change, speed, and the autopilot is on. So we can disconnect the autopilot like this. You will see the warnings here coming up if we press this switch here, which is the autopilot engage and disengage like this. You will see the autopilot is disconnect, the warning with the red letters here. Autopilot disconnected. So we go again. Engage again the autopilot and use this switch here in the yoke, the autopilot disengage switch. You will see again the same warning, and the autopilot is disconnected with the red letters, and we re-engage again. We confirm the cancellation like this. So now we have the manual control like this. So that was all for the autopilot flight director system panel. Now we'll have to come to the thrust levers. So you can explain you how to use the thrust levers. We have 53 minutes left for this video time trend. So I will have to show you how to use the thrust levers. You can see we have the speed brakes. They can extend only when we have the thrust levers in the idle position. We still have the warning, cancels out and so on. We have the flaps also here, up and down. I have to start explaining about things you can see in the upper and the lower ECA. So you can see the flaps. Also over here you can see the landing gear is down. Over here the normal landing gear up and down, and the alternate. You can see the extend and the retract over here. Some other terrain override. The auto brake. Let's set to takeoff or off, and the flap limit speed. So you can see the Boeing 777, also the mark of this airplane. I forgot to mention you have also the other side flight director here, and the vol localizer, and the approach for autoland. So also we have a couple more things. So you can see the total fuel on board over here in the upper ACAS, 104.8 thousand pounds. The duct pressure, the outflow pressure from the engine below the high pressure compressor. So we have a couple more things. You can see the speed brakes, as I told you, retract and extend, the thrust levers. Here is I told you the autopilot disconnected, and this is the horizontal trim for the aircraft, the stabilizer, so you can pitch up and pitch down. The horizontal tail with this switch. You can see the aileron trim position also here, so you can set the aileron trim here. You can see the rudder trim here also, and the horizontal tail trim with that. You can see how far it goes up and down. The horizontal trim stabilizer over here. This indication of the lower ACAS in degrees. So you can see the green band is for takeoff settings. This is so you have normal and alternate horizontal trim stabilizer. Also this tab you can use for manual trimming, and have Also auto trim function, which is used by the autopilot and the auto throttle in the flight director system. So in case you have a failure in the CODR hydraulic systems, you can disconnect the auto trim function like this. You disconnect and you have only the manual trim using this, the normal and the alternate, and also this one, trim up and trim down, as you can see these functions here. Also I will show you now. You can see these displays here. You can see I can move the thrust levers. The speed brakes will retract automatically if they are extended. You can see here in the thrust levers we have the auto throttle disconnect like this. This switch you can press in and disconnect the auto throttle. We have the takeoff ground switch, the thrust reverse. So I will show you now the thrust reverse. So you can see here is the N1, which is the low speed, low starter shaft, and the low pressure compressor and turbine of the turbofan turbocharged engines, the G90, as I told you, the General Electric 90, the exhaust gas temperature per engine. You see the green 104.6% is the target maximum takeoff thrust will go around, takeoff go on, and maximum continuous thrust, exhaust gas temperature, left and right engine information. You can see the idle thrust setting right now because the thrust levers are at idle. If I move them up, you will see also the thrust levers indication change. You can see the difference between the actual and the commanded thrust. You can see the N1 with the N2, which is the low speed, the high speed, starter and shaft, and the high pressure compression and turbine of the turbofan turbocharged engine. The N2 stage, the left and the right engine. The fuel flow per engine per hour is thousands of pounds right now, or thousands of kilograms. The oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine, as you can see. So we have also the variable thrust like this. You can move one thrust lever at a time forward. You will see the differential thrust like this. One is 40, one is 32. You can see more temperature rise. So we can move both the same way, and again the other side. So you can see the variable thrust, one thrust lever at a time. Again, you can see one and one is higher than the other, and also the temperature and fuel flow. So you can use that in case of an emergency. We also have, as I told you, this is the fuel flow control for the left and for the right engine. You can set off the fuel flow. We have also the fire extinguisher for the left and the right engine. We have the weather radar over here, the radio communication panel, the frequencies, the TCAS system, the transporter. They give me an DC transporter over here, and the TCAS system that transmits or receives the position of other aircraft and generates the warnings, the traffic, collision and alert system. So that was the TCAS system. We also have over here the thrust reverse. As you can see, you can pull up this handle over here, and you reverse, you open the blocker doors and reverse the flow of air from the turbofan turbocharged engines. So you can slow down the airplane in landing or in order to takeoff. You can deploy again. You have deployed the other side also. again close and open the thrust levers, and the other side for better view maybe. You can see the speed brakes also retract. So this is all the explanation for the thrust levers. Hope you like it. Now I'll show you. You can see the speed brake retracts automatically. So I will show you now also the navigation display. I forgot to mention. We can see the terrain over here, the level red, green and yellow. You can see here is the Switzerland, here is France, and here is Germany. You can see the airports with the blue cyan, the name. Also the position of the aircraft, the GPS position, the required navigation performance, the required navigation performance. You can see the radar scan, the terrain elevation, mountains. You can see the sea in the farther distance. So we have 6,100 right now maximum elevation. There may be yellow and 0 feet is green. Other aircraft flying around us, and the distance range in nautical miles 160, 320, and the magnetic heading and track. You can see the scan. You can change it and show you closer like this. This is the closest you can see with this scan. 2,800 now. Also we made it like 40 nautical miles. And the farthest you may also see the sea farther away. So I will come again to the thrust levers, the explanation of the thrust levers. So we have 30 minutes approximately for making the engine start demonstration. So we have the General Electric 90G90 installed in one in the left and one in the right wing. Two engines, turbo-100 engines installed in this Boeing 777 for symmetrical thrust and redundancy. We have also each engine contains gearbox with FADEX. The FADEX are the full authority electronic control computers that control and display the indication and monitor and display all the indication and information received from the engine functions like the N1, which is low speed, low stutter, fast compressor, and low pressure compressor and turbine. The turbo-100 with the engine, the viscous temperature, the fuel flow per engine per hour. The N2, which is the high speed starter, and have the high pressure compressor and turbine, and also the oil pressure, oil quantity, and oil temperature. The vibration of the N2 stage of the engine. We also control the engine start, engine shut on, the fuel valves, and also we optimize the fuel efficiency of the aircraft. If we climb higher, we have lower air pressure, air density, and temperature, decreasing below the zero. Also the oxygen level is lower than the sea level or the level we are right now. So also the aircraft flies with higher airspeed, so we have a different rate of intake from the front fan stage of air per second for compression into the engine and the fuel air mixture. Also when we descend, we slow down the aircraft and we have higher air density and oxygen levels and temperature, so we need to actuate the fuel air mixture every second instead of doing this manually. The FADEX, the full authority, uses electronic control computers do this automatically. Also we actuate this using the thrust levers position command. If you want to adjust the thrust manually using the thrust lever, you command the FADEX. Also, if you use the auto throttle or the airspeed select mode in the autopilot flight director system panel or the LNAV and the VNAV, we have the same modes for climb or descent as I told you, or cruise and approach and landing. fixed thrust and variable thrust of engines. So this controls the aircraft totally. Also the aircraft engine functions and thrust produce. Also if we have an overpressure inside the engine, the fadecs open the system in the United States outflow valves into a higher setting to relieve the pressure inside the engine. We have another pressure to close it into a lower state, so they increase the engine pressure, so they regulate also the pressure of the engine and the rotation speed of the starter and fan blades, the low and the high speed and the low pressure compressor and turbine and the high pressure compressor and turbine. So it's a good thing to have the fadecs installed in your G90 General Electric 90 engines. So we'll talk to you now about the flight theory of the Boeing 777-300ER. I will explain you about I will show you how we calculate the takeoff speed. For this aircraft right now we have 254,000 kilograms of takeoff weight, about 524,000 pounds, which is below the maximum takeoff weight. We have about 46,000 kilograms of fuel on board in the left and the right wing end fuel tanks, and in the center tanks, or about 102,000 pounds below the maximum takeoff weight also. So we have about 30,000 kilograms of passenger fuel, or about 46,000 pounds. So in total we have 254,000 kilograms of 521,000 pounds for takeoff weight below the maximum takeoff weight. So we need to use the flap settings of 15 degrees and 4 degrees of horizontal tail trim stabilizer for takeoff. So I will show you. I will use the fine management computer to calculate the takeoff speed. So we will use the thrust from the engines, the propulsion, the forward thrust propulsion, to accelerate the aircraft into the runway. So we're gonna use also the runway conditions, the runway length, the temperature, and the barometric pressure, altitude, the wind direction, and if the runway is wet or dry or ice, and the temperature of the air and the pressure. So we're gonna calculate the takeoff speed. We need to accelerate for this takeoff weight 254,000 kilograms or 531,000 pounds. We need 15 degrees of flaps and 4 degrees of horizontal trim stabilizer positive. So we need to accelerate to about 154 nautical miles per hour, or 154 knots for takeoff, or about 170 kilometers an hour to overcome the stall speed. The stall speed is going to make the wings of the aircraft not generate the necessary lift force. The lift force is the force that generates that overcomes the weight of the aircraft as the aircraft is flying. The weight is the mass of the aircraft times the acceleration of the Earth's gravity, depending on where we are in the world. Also, the thrust from the engines overcomes the kinetic and static friction in the surface of the aircraft from the air. So, I will talk to you now about Newton's physics, about the Newton's physics, first, second, and third law of kinematics of motion, the Bernoulli theory of the fluids, and aeronautical and aerospace engineering. And we have about 30 minutes left for this video to end. So I will show you the outside view of the aircraft and explain you how the aircraft generates the lift force using the airflow of the air mass as it accelerates to the takeoff speed and as it flies. Also, I will show you later the flight controls. So I will start with that. So we can see here. So you can see here we have the outside view of the aircraft. So you can see So you can see the wings of the aircraft, they hold the weight of the aircraft in total. You can see the engines are installed symmetrically in the left and the right wing, and they move the aircraft forward. They generate the forward propulsion vector. We have the vector from wingtip to wingtip. We have this vector, the longitudinal axis, that transverses also the center of gravity and the horizontal tail and the vertical tail stabilizer. So we have the mean aerodynamic chord position here, 25% of the Mach in the wings. It's the position when the maximum aerodynamic lift force is being produced, and also where the stall of the wings begins, where the airflow becomes detached from the wings and the aircraft starts to fall, to lose its lift. So we have the center of gravity of the aircraft approximately here with the mean aerodynamic chord position, 25% of the Mach. You can shift the center of gravity forward or after this position by shifting passenger, fuel and cargo inside the aircraft. You can see the wings of the aircraft. So I told you we have the propulsion from the engines, and the wings they generate deflection of airflow, and also you can see the bottom surface of the wings is more flat than the top surface. So as we accelerate for takeoff, the airflow of the air mass moves slower below the wing. So using the Bernoulli theory of fluid, the air has higher pressure below the wing, which pressurizes the aircraft wings up into the air with the aircraft weight. With them, also the top surface of the wings, you can see is more curved. It has higher curvature. So using the Bernoulli theory of fluid again, you can see the airflow moves much faster above the wing. So the air has lower air pressure. It has negative pressure above the wing. So this creates an suction above the wing. It sucks the aircraft weight up into the air. So we have the differential pressure up. Lower airspeed of air below the wing with higher air pressure, and also we have lower air pressure above the wing with higher airspeed. So this is the explanation. Also we have the center of gravity and the moment arm. The moment arm is times the distance from the center of gravity all the way back to the horizontal or the vertical tail, or the ailerons and the spoilers on the left and the right wing. So it's times the distance, center of gravity all the way back, horizontal tail, over the surface area of the horizontal tail or the elevator or the rudder, times the airflow of the air mass per second, times the acceleration of the air gravity. So you have the moment arm force that pulls the aircraft up into the air, or you can descend down, or you can make turns left and right around the center of gravity and the vectors from the thrust from the engine. So this is the explanation you also use for HPPL, transport pilot theory. So you generate some nice iterations with these theories. Now I will talk to you about the flight controls of the aircraft. I would say I use the side stick to control the flight controls in this simulator, the Boeing 777-300ER. I use the side stick. So I will show you this function now and show you also the outside view. So I use the Lszh Extreme 3D for this Microsoft Flight Simulator and Pmdg simulations. So you can see here I have the side stick. You can see I can move the side stick up and down. I move the elevator up and down, so I can climb or I can descend. I also move left and right. I can make turns, bungle left and right using the ailerons and the spoilers. Also is connected to the other side, as you can see. So you can leave also neutral. You can also use the horizontal trim stabilizer over here, which is located, as I told you, over here. Also the thrust levers for the engines like this. So I have full control of the airplane using the side stick like this. So you can climb, you can descend, you can bunker left, bunker right, horizontal trim stabilizer, also the rudder pedals, make turns left and right like this, the yaw axis. Also I use this nozzle steering over there for the ground operation. So you can see the side stick deflection is proportional to the yoke of the Boeing 777-300ER. So we have a full deflection like in the airbag. So I will show you now the outside view of the same things again, and how you can see the flight controls of the aircraft moving around in proportion to the side stick. So you can see here again, you see again the side stick. You can climb, you can descend, as you can see. Climb, descend, the horizontal, the elevator of the airplane, the yaw, the rudder, and also the ailerons, make left turns, make right turns, and having coordinated flight controls. Also the horizontal trim over here, the stabilizer and the thrust levers. So this is all the explanations for the flight controls. Now we'll show you inside the aircraft the overhead panels and make an engine start demonstration. Now we'll show you also the lower ACAS and then set up the flight management computer and fly this airplane for like 30 minutes. So I have to be brief now. So now we'll come to the overhead panels section. We have about 10 minutes, so you can see inside the cockpit a different kind of view. Over here you can see we have again the same panels. You can see the speed brake again, extend, retract, extend, the flaps position. You can see here 15 degrees for the flaps. Also the thrust levers again. You can see the parking brakes again here, up and down. The auto trim, disconnect, and the flight management computer. Also we have the displays here, better view as you can see. Also the autopilot and flight director system panel again. You can see a nicer view over here. The landing gear. So now we'll come in the overhead panel. You can see here is disconnect for fluid from the flight controls. Here is the circuit breakers of the electrical system. I will explain in another slide. We have here the ADIRU, the air data and inertial reference unit that controls and displays all the air data and the GPS position, the gyroscopic acceleration and deceleration, the airspeed, the altitude, all this using the ADIRU over here. The primary flight control computers, the thrust asymmetry compensators, on and off, the electrical, the battery, the APU in the start, the APU generator battery, and the left and the right is in the great drive generator, the backup generator, and the left and the right bus type controller. I will show you also later. The window heat, the passenger oxygen here, the runway proximity override. So we have the hydraulic here. You can turn off all hydraulic tanks. You will see the fault coming up. Hydraulic pumps, left engine, right engine, and the electrical. So you will see the fault messages coming up now. So we have over here flight controls, hydraulic pressure demand, C1, C2, primary, spoilers. So we need to reset everything. We keep losing hydraulic. We turn them on. And back to the auto once they're on. So now also here's the electronic engine control. For the engines, also the cargo fire. Electronic engine control, you see the auto start on and off like this. The fuel jettison, we can dump fuel inside like this if we on this. Also select the nozzle to dump fuel. The exit valves, the left wing, right wing, and the center tanks filled on board. You can see the center tank is empty. Again, for this flight, wing and engine are the eyes. This is the lighting system, the windshield wipers left and right, and also we have the cabin pressurization, which uses admitted pressurizer, automatic manual. Now we use the outflow valves for climb and descent, and select the landing altitude. Back to the auto. Now we have the bleeder from the left and right engine. I'll show you now. Also from the APU for starting the engines. Turn off everything, you will see the bleeder fault over here. Also no cabin pressurization. So you will see some, also the hydraulic fault, bleeder isolation, hydraulic pressure, C1 and C2. So we readmit everything, the bleeder from the left and right engine and the APU, hydraulic pressurization, wing and engine at the ice, air conditioning, and the pressurization of the cabin, and engine start. So I'll show you one last step. Over here in the virtual cockpit, we need to make the engine start now. We have a couple of CDU and ECL, couple more minutes left, so we have the display on, the engine, the status. You can see the APU is on, the hydraulics and the oxygen, the checklist, normal menu before start, what we need to do. If we have a failure, also communication, navigation. The doors, you can see the doors of the aircraft are closed and the cabin can be pressurized. The landing gear, the pressure inside the tires and the temperature of the brakes. Electrical, I showed you before. You can see the main battery, the APU battery, the left and the right engine, current, voltages, and the APU is running. Also the hydraulic fluid, left and right engine driving. You can see the quantity of the hydraulic fluid and the pressure, where the hydraulic fluid goes, the system that needs hydraulic fluid pressure, the left and the right engine, the low and high pressure fuel valves, the APU is being fed from the left wing tank. You can see the center tank is empty with the yellow crosses. The minimum fuel temperature here minus 37 degrees, it freezes below that. The air system, you can see the bleeder from the left and right engine. From the APU we need for starting the engines. Also if we advance the thrust levers, you will see the bleeder from the engines increases rapidly. Also the flight controls, the last section over here. For these displays, you can see I can move the flight controls around like this. And I have full control also the other side the same. So you will see everything is working here in this display like this. I move around everything. So I'm going back to the engine. We go to the engine start, virtual cockpit, turn off both engines, set on. So you will see in the outside view over here, the right and the left of main engine is going off. We have the engine start also, automatic. engine auto start left and right. There is no fuel flow now, only pressurizer inside the engine. So we need to start this very quickly. We need the fuel. So you will see the fuel flow from 0 over here, and the pressure, and both engines, the right and the left wing, are start. Both turbofan engines. You can see the spinners and the fan. So this is all for the auto start. Now we need to make the flight plan, the last step before flying this airplane. And we have only 1 minute left. So we have the menu, FMC, the motor position, initialize, the reference position, GPS position, as you can see over here, inertial GPS coordinates. 0 fuel weight, gross weight automatically inserted, 5%, fuel 35,300, the flight level over here, and the cost index 100%, minimum fuel temperature, and we have from this airport the Lszh 8, copy paste back into this airport, runway 14, and we have the departure for this runway 12, and the arrival again ILS 14, select the next P1 alpha and the Amity, legs trans alpha, activate and execute. So we have 15 degrees of flaps, center of gravity automatic, 35.8% with the trim, and also the takeoff speeds selected. And here's the whole flight plan over here for this airplane. And now we are ready to take off. So we just the parking brakes up and advance the thrust levers and move into the runway. So we have like take the confirmation the runway is empty and move into the runway. You can see also we use the steerer for the nose wheel steering, and the rudder pedals align with the center line over here. Also the ILS parking brake set again. You can see the scan from the radar. We'll fix the reins, the LNAV is on, the flaps are set, the thrust levers up, and the horizontal trim stabilizer. So everything is normal in the indications. Also the engine flash for this. So this is the view from the runway we're gonna use for takeoff. So I'm gonna have a nice review over here like this. Disarm the parking brakes and go, and we have like 16 more minutes left for this video to end. So we go into the takeoff. As you can see, we have V1, we rotate, V2. So we pitch up very slightly, as you can see, not hitting the tail of the airplane into the runway. Retract the landing gear like this, positive rate of climb, as you can see. So you can see the information here. We have the airspeed. We are only 1,700 feet above the ground level, as you can see. 2,400 feet above the ground level, 4,000 feet above the sea level. We climb with 7,000 feet per minute. You can see the first waypoint here, and the flight plan, also the terrain scan. So you can see we have the climb here, the rate of climb, the airspeed, the stall speed is here. We need to avoid the stall speed, so we pitch down the aircraft and increase the airspeed. Also here the flap warning. So this is after takeoff. Now we start making the turn. So we have like 15 more minutes left for this video to end. We go to the first waypoint. Maybe we're gonna, yes, 9,000 feet. I'm gonna show you also the outside view now as we keep flying. Climb over the Zurich, this beautiful view. We have the Zurich here, the Switzerland, and also the galaxy here, the night sky. So maybe a closer view. You can see we fly now with about 500 kilometers an hour, or about 500 kilometers an hour, about 250 meters per second, as you can see. A nicer closer view over here of the Boeing 777, and now we have to come back inside of the cockpit for the rest of the turns and cross the first waypoint. 14,000 feet. And we have about 30 minutes left, 3 minutes for this video to end. You can see the beautiful view over here. So this is our spacecraft for tonight, the Boeing 777-300ER, the Galaxy, and I'm gonna come in a couple of minutes here. So we keep climbing, as you can see, 17,000 feet. The first waypoint here we need to cross. So you will see the first waypoint is for when 2 nautical miles away, the distance it is located, and also the other information in the navigation display. So we have about 12 more minutes left for this flight to end. We are 30,000 feet. So now we're going for the second waypoint. You can see the airspeed is Mach 0.49. The stall speed warning, we climb with 4,000 feet per minute. Also the autopilot information, the engine thrust. So everything is set over here inside the cockpit. As you can see, 33,000 feet, keep climbing. So now we reach the climb cruise altitude over here, 35,000. We need to pitch down a little bit, leveling off. Also this increase the airspeed, as you can see. Retract also the flap and hold the manual over here. Also maybe we're gonna increase the airspeed. So you can see here we have the chemtrails and the contrails. So this is our spacecraft. For tonight, the Boeing 777-300ER. We cross here. We cross through. We have the Germany in front of us, and the France in this side. So perhaps I will increase the airspeed now. So this is here, and we have about 9 more minutes left. So this is the Germany, the Bayern Munich side over here. Increase the airspeed. Of course, we have the lake here, as you can see. So we hold now stable manually as we overflying this level. So this is our spacecraft for tonight, the Boeing 777-300ER. We fly with about 900 kilometers an hour right now, or 300 meters per second, and cross the Bayern Munich and the Bavaria and the France on this side. The Bayern Munich in front of us and the Switzerland here. So let's come back inside onto the wing view. And we have about 8 more minutes left for this flight. As you can see, we need to cross, and I told you we have the Germany here, over here this side, Bayern Munich. So now we are 36,000 feet above the sea level. So I hope you like this view of the Boeing 777-300ER, and we're going back home to the Zurich airport, as you can see. And we have also the frozen vapors, as I told you, chemtrails and the contrails. So 35,000 feet above the ground level, and we have about 6 minutes left for this flight, so we need to start the descent in a couple of minutes. So descent, we're going manually right now, and the airspeed, decrease also the airspeed for the descent. So we keep descending to the 3000. Again, a nice view with the galaxy, as you can see. And we have like maybe 5 more minutes for this video to end. So keep descending. So we have the information here for the approach. the whole localizer also, and we select here the reference approach airspeed and flap limits. As you can see, keep descending. Now we keep getting closer. This is the landing gear, and the airspeed is gonna be lower than that. For the approach, also the flaps over here. And we have like 4 more minutes left for this flight. 4 more minutes, so we need to approach faster. You can see we fly manually, 7,000 feet, 6,000. We have a couple more minutes left for this simulation trend. For the video time, actually, for the record. Two more minutes. You can see we fly manually. You can see we fly manually with the flight controls. Also have the Lszh localizer, the information here. As you can see, the primary flight display, the vertical glide slope, the airspeed, and the Lszh localizer. We keep descending. We are aligned now with the localizer and align ourselves with the rudder pedals also, and the yoke, as you can see. Also the manual thrust with the automatic connected. We're gonna have the flare in a couple of seconds. We're gonna level off. So increase the rate of descent. Level off now. 10. Just touchdown, beautiful touchdown, parking brakes and reverse thrust. Reverse. You can see we're slowing down. So we made a nice, beautiful touchdown. You can see here is the nose wheel. You can see the nose wheel, the tires and the screws of the nose wheel is not broken. Everything is perfectly safe. Also the landing gear, there is no breakage of the tires for buckling of the landing gear, the metal parts, so the aircraft stands up in the landing gear. And the nozzle, you can see the nozzle also no buckling, here the metal parts, and the tires are perfectly fine, like some other pilots are doing. So you can see where we landed here, the full view, runway 14. Also you can see this view again, the landing gear and the nozzle again over here, the front, the tires, so the aircraft stands the way it should be in the runway.